Yeah, I guess I'll record this. Week 12, day 3. It's Halloween party day. We're going to do a little bit of code. We're going to go over this very buggy code that somebody asked help for on Reddit yesterday. And we're going to go through it together, and I want you guys to be critical of it, you know. And you don't even have to worry about positive criticism because this person probably is in our class. So learning how to read other people's code and find bugs in other people's code is a good skill to have. Just like with a foreign language, you need to read and write. And most of what we do is writing, but reading is important as well. Okay. And one of the best ways of getting good at computer science is to be a TA, actually. If you do what Corrente is doing and Mincorelli is doing, students come in, their code's buggy, you have to read their code and figure out where the bugs are, and you develop those skills to quickly home in on where the bug lies. And if you can do that with other people's code, you can do it with your code. So it is definitely a worthwhile endeavor. You can apply it at the TC, the Tutorial Center, and get a job grading people's, helping people with their homework assignments. Okay, so this post was from Reddit yesterday. It has, in my opinion, about over one bug per line, and by bug I mean thing that I would change. Right. So what we just went over before I started streaming was this part up here is fine, I guess. String is a little bit redundant, but Bjarni Strustrup recommends you do it anyway because there's no guarantee technically that IOStream includes string for you, or it includes part of it, not the whole thing. So this is fine. But they're using namespace standard, and then still down here using the std : which makes, like, why? Yeah. The whole point of doing this is so you don't do this. So clearly just copy pasting mentality, or not understanding what something does, which is bad. You always want to understand every line that you're doing. And if you don't understand it, go into cppreference.com, Google it, figure out what it is the line's doing, because you do not want to have any, like, I don't know what it does in your code, because if you do, your code's going to have bugs, almost guaranteed. And this code here has bugs. So where we were right before I started streaming was I was kind of criticizing this right here. So he makes the variable, and then he initializes it down here. And there's absolutely no reason to do that. Like, if you're going to do it this way, then I would initialize these things to 0. Character 0 is the null character, which won't print out anything. It's fine. Size should be initialized to 0. Or, even better, is I would just write, it's not int. I would write char character here and int size here. And then there's absolutely no benefit to declaring it, then initializing it in 2 separate places. It makes your code more vertical. It makes me feel very nervous and anxious having uninitialized variables just hanging out. You could initialize them to 0, but there's no reason to, because you're giving them a value right here. And sure, the optimizer would optimize that away, but it just makes your code look a lot nicer when you say int size equals something rather than int size semicolon, and then initializing it a couple lines later. And they've got like 2 lines in between the two, which makes no sense to me. Like, you're doing the user input. Oh, I mean, I guess that's fine. But these don't need to be up here. Like, there's no reason to declare them and then use them later on. You can just declare them down here. I suspect this person might have come from C-World. So in C, back in the day, not modern C, but back in the day C, all of your variables had to be declared up top, like this. And so some people still write code. And that way of coding, by the way, is terrible. People did it because that was what the language mandated, not because it was good, but some people, still do it this way. They're like, I want to see all the variables in this function. And there it is. And then you end up having uninitialized variables or redundant code and things like that. So better way of doing it would be to just not have these lines here at all, and to just say char character equals user input and int size. Okay. So so the code says it's supposed to input a character and a string. What is the input actually inputting? Right here. So the problem says you're supposed to input a character and a string, like P and apple, or A and apple. What is he actually inputting? What's the mistake going on right here? A mistake, because there's more than one. He's just reading the string. He's not actually reading the character. Now, he does something even worse, which is this. Right, so this should be CN double right arrow character double right arrow user input. Right? Because he should be inputting a character and a string, in which case you would declare the char character up here. As it is, he's setting the character to be element 0 from the string, which is baffling. So it would be A. You know, if the string is apple, the character is going to be A, which is not what, like, I don't even know where that came from. You know what I mean? Like, if the problem was count the number of times the first letter in the word appeared, this would make sense. But there's two problems here. In addition to the fact that this is just wrong, like, the character we're searching for is not the first letter of the string, it's just wrong. But on top of that, there's two more bugs. Anyone see what they are? One line of code has 3 problems with it. Like I said, this code averages over 100% buggy lines. Yeah, he is not bounds checking, right? So it is possible for the user to enter a string of size 0. And if you have a string of size 0, which you do by hitting return, if you have a string of size 0, then this will go out of bounds. Okay? If there are no elements in the string, that goes out of bounds. And technically it'll pull like the null terminator or something like that out of it, but it's still going out of bounds. And that's bad. He's not checking to see if the input is valid, right? Like, error, you must type at least one letter or something like that, you know? So that, and rather than using square brackets, so that it's going to go out of bounds, which we call OOB. OOB if the string size is 0. What's the other problem? Instead of using square brackets, what should he be using? Yeah, .at. And why? What's the difference between .at and square brackets? Well, .at does bounds checking for you. He's not bounds checking anywhere else. You got to bounds check somewhere. Might as well use .at. And you know, if you considered a weird edge condition that somebody doesn't type in a string, then .at will be like, yo, you went out of bounds, and it throws an exception and it kills your program, and it's fine. It's fine. It's actually much better for it to kill your program than you to just randomly read from RAM and hope that your code works correctly, which it may or may not do, which is really terrifying. So this is why I recommend that new programmers always use .at, because a lot of times you don't have enough experience yet to know if this will always be in bounds or not. And in fact, anytime I see square bracket from a new programmer, my immediate thing to do is be like, can that go out of bounds? And a lot of times the answer is yes. In fact, both places here where the person is using square brackets, they will go out of bounds. This, some of the time it'll go out of bounds. This, all of the time it'll go out of bounds. And that's why you use .at. .at is a safety measure for you. Yes, square bracket is faster, but in actuality, no. Because you should be bounds checking every time, right? Like every time you're doing something like this, you should have somewhere in there an if statement saying, you know, if the size is at least 1, then do it. So you can't really escape the bounds check. Now, do you need to bounds check on every character? Here, I would still do it, because who cares? It's 0.01 seconds slower. Who cares? Who cares? You're not doing high frequency trading for the stock market. It's much better to be safe than to care about an extra, you know, millionth of a penny worth of electricity. You're not going to notice any delay. Okay. So, yeah. So never write square brackets, especially in C-Side40. You know, there are times like in the last class when I was doing image processing, I used square brackets after I had bounds checked it. So I'd use .at once, and then after I knew that I, j, and k were within bounds by using .at I, .at j, .at k, then I would use square bracket for the other ones because I know they're in bounds. You know, so that's me. I've been doing programming for a while. But in your case, there's no downside to using .at for just everything. You're not graded on execution speed in this class, but you will be graded and judged, mentally judged, if you use square brackets. Okay, so there's 3 problems with this. Okay, size is equal to user input dot size. What's the problem here? So let's say we've rewritten it already to int size equals user input dot size. What's the problem? Are you still going to have a daily quiz for today? Yeah, sure, why not? He didn't declare size earlier on. He did. He said int size, and so I just moved it down here. I cleaned it up a little bit. And one of the other benefits of doing it this way, when you do the declaration and initialization at the same time, is that you can actually make these things consts, which they probably should be. So I would rewrite his code saying const char character equals this, const int this equals this, because neither of these will change in the execution of the program. And by marking them as consts, there's optimizations that become allowed, and also it prevents you from accidentally changing them. Right? Count should not be a const because it's going to be counting, but these variables here should be consts because they don't change. But he couldn't make them a const if he did it this way, because const variables can only be set when they're made, and so you wouldn't be able to make them a const. So again, this is another reason why we wanted to declare them all together like that. It is redundant. No, I mean, kind of. I mean, he technically doesn't need to do it. He could have just put string.size in here. But I mean, you know, whatever. It's, I guess, readable or something. I don't know. Yeah, it is technically redundant, but the type is wrong. The type is wrong. This should be a size underscore t. Because the type coming out of here is a size underscore t, which is an unsigned integer type big enough to hold, big enough to address any part of RAM. It's an unsigned 64-bit integer. And it changes based on the architecture you're on. If you're on a 32-bit system or a 64-bit system, the size t will change as well. Int, it will work as long as your string is smaller than 2 billion characters, which is probably reasonable, but even still it's better to use size t here just to match the type coming out. Or you could have used auto, either way. Auto would work as well. So, in general, you want to avoid mixing and matching signed and unsigned integers. It leads to chaos and trouble. All right, so over here, the for loop. What's wrong with the for loop? For int I equals 0, I is less than or equal to size, plus plus I. What's wrong with it? What's the pattern that we always do for for loops? And this is why I teach for loops in a specific pattern, because it lets you recognize when people screw it up. Yeah, it should be less than size. Should be less than size. That's the pattern. For I equals 0, I is less than blah, I plus plus. It's called the half-open code pattern, from 0 to size, not including the size. He included the size. So he goes out of bounds, guaranteed. This code goes out of bounds every time, and because he uses square brackets instead of .at, like a normal person, he doesn't notice the fact that he's going out of bounds literally every time. And this also should be a size underscore t as well, because it matches the type of the thing we're comparing against. That's just a minor warning. It's not a big deal, but yeah, still two things here. The plus plus I, that's actually probably more correct than the way I do it. As it turns out, though, it's going to compile down exactly the same, so you can use plus plus I or I plus plus. It makes no difference. It will simply increment the variable. So, yeah, but by using a less than or equal there, he has an off by 1 error that's going to have him go 1 too far every time, and because he didn't use .at, he doesn't even know it. Like, if you look down here, he doesn't even realize the fact he's going out of bounds. Maybe here, but guaranteed here. He doesn't even realize it. You know, this is why we always use .at when we're starting off in computer science in C++. Okay, so if the user input matches the character, what's wrong with the if statement here? To be fair, I think we've all put a semicolon after an if statement before. I think we've all done that at one point or another. We just get used to it. It's an if statement. Statements end in semicolons. Boop. You know? The trouble is that he indented the next line here, and he indented it thinking that if every time character matches the user input, including the off by 1, it would increment the count. But what's happening is that it is simply incrementing the count every time, because the semicolon here says if they match, do nothing. Semicolon by itself is a valid line of code. It means do nothing. And if he had warnings turned on, it would have warned him about that semicolon there. and it would have warned him about the misleading indentation here. You can see he indented it in here. He might be a Python programmer or something, where indentation is used instead of curly braces. But there is a misleading indentation warning that would say this is indented over as if it was part of the if statement, and it's not. It's not part of the if statement, but he is not compiling his code with warnings turned on. He needs to be compiling his code using switch. He needs to be compiling his code with G++ -w all -w extra main.cc, and that would turn on all warnings and extra warnings, which are more than all warnings. And he also should be compiling his code with -f sanitize equals address, and that turns off address sanitizer, which will detect his out of bounds problems as well. If you just get in the habit of compiling your code this way, which is what my compile shell script does for you, by the way, it does all that stuff for you, so you don't have to memorize it. Just type compile main.cc, then all these warnings would pop up and you could fix it. As it is, silent. This is all technically correct C++ code. It compiles, and people think, well, if it compiles, it must run correctly. And as we can see, the number of mistakes this dude's making, the answer is no. There's no guarantee it will run correctly if you compile it correctly. So this should be part of the if statement, but it's not, and so it has bad indentation. And then what is this continue doing here? The if statement does literally nothing. Yeah, the whole thing's wrong. And it's out of bounds. It not only does nothing, but it does so by violating memory. It's exciting. What is the continue they're doing? So the continue is why he gets 2. Actually, the continue does nothing. Because when you get to the bottom of a loop, it's like there's a continue there anyway. When you get to the bottom of the loop, it loops back up to the top. What does continue do? It loops back up to the top. So the continue is utterly redundant and pointless, and it will baffle people having it there, because you do not need a continue at the bottom of the loop. So this person doesn't even know how for loops work, bro. You know, that kind of thing. It's not like I'm making fun of him. It's just, you know, if I was doing a code review at a company, it's like, why is that there? Did you mean to have something else there? You know, it is redundant. Yeah, it does nothing. Because when you get to the bottom of a loop, it goes to the top of the loop anyway. So putting a go to the top of the loop on the very last line of a loop is what it would do anyway. So just erase it. Okay. And it's also misleadingly indented. So that's actually 2 bugs in one. One, it's redundant. 2, it looks like it's part of the if statement when it's not. Yeah, so that's exciting. And then we come on down here, and we've talked about how they have the pointless STDs. And also technically return 0 is also redundant. So that is redundant. That is redundant. That probably could be put inside of here if you wanted to get rid of size entirely. Yeah, I'm not going to nitpick too much on that. Yeah, this is just wrong, getting the letter from the string. And then this is bad indentation, so that should be moved over there. Main should be moved over this way. Yeah, so it works out to over a 1.0 errors per line due to how many multi-bug lines the user has. It would look cleaner without size there, yeah. So if I had to implement this code, and I wasn't mean to the person when I replied on Reddit. I just kind of went through each of the different things that they did, you know, completely wrong. And if I had to do it, it looks something like this. Character C, string S, and C and S. If S dot size is less than 1, die. So if they type in a string to search for that doesn't exist, or if they typed in something that didn't belong, then we'll just print out bad input and quit. It's CPP questions. So CPP_questions on Reddit, and people post things. Sometimes they're good questions. Sometimes people starting out. So yeah, I don't know how he's getting to either. It's a bit strange. Okay, so that, and then basically, I think there's a count function in the standard library, isn't there? CPU reference count if, something like that. Return counts the elements that are equal to value. Count s dot begin from the beginning of the string to the end of the string. A apple, there's 1. P apple, there's 2. E apple, there's 1. Z apple, there's 0. So there you go. Yeah, so that's how I do it. It's part of algorithm, I think. Part of algorithm, yeah. So it just counts how many times the letter appears. Easy peasy. Knowing the standard library is very useful. Yeah, I mean, it's not like I couldn't write it anyway, but yeah, I would just use count because it already exists. So why wouldn't you? Okay, so that's our talk for today. If you have any questions about the image processing assignment, which is due next Wednesday, just post them on here. We're going to do the gaming in a different channel so that we keep our academic and gaming stuff separated. We're going to play another game of Among Us, and so if you'd like to play or watch, I will go and fire up the game now. And actually, if somebody else wants to host, I'm actually hungry. I've been basically lecturing nonstop. I had a meeting at 8 o'clock in the morning, so I'm actually hungry. I'm gonna go eat some food. So I'm gonna stop streaming now. If somebody else wants to host a game of Among Us, I'll pop back in and play some more in a little bit. Okay. So that's it for today, guys. Hop on over to Halloween 2021. Post your cosplay, get extra credit. If you participate in the gaming or anything, just go on Canvas and just say what you participated in, and you'll get extra credit. It's just you guys have been working hard, so we're gonna have fun today. You know. So if you want to leave. It's fine. You're not gonna offend me. You can just bail out if you want. Okay. So that's it for today, guys. I'll see you next time.